Hey everybody. So I wanted to go through and do a small video lesson for you again on estimating square roots of non-perfect squares. I think the Zoom sessions went pretty well today, but I do think that this will be a little beneficial for you to see again on how to solve these, especially since I'm going to be out on paternity leave starting tomorrow. So just kind of walk you through an example, kind of thought process on it. Okay. So when you start this assignment, question 1 is going to ask you to approximate the square root of a number. In this case, it's 51. I know we looked at a couple different examples. I think I'll do 2 examples so you kind of get the hang of what you're doing here. If you need it, I would highly suggest having this slide up so that you can go back and forth between the two. Okay, so square root of 51 is what I am looking for, and I'm just going to grab a scrap sheet of paper, and I'm going to write that down to make sure that I know that the square root of 51 is the irrational number that I'm kind of evaluating right now. So the first step that I'm going to do is I'm going to look and see which perfect squares the square root of 51 falls between. Now, I'm hoping that you guys are getting much, much better at it and that you would know that it's 49 and 64. So it falls between these two. So we know somewhere on the number line that the square root of 51 falls between 64 and 49. Now, when you go to start testing these intervals, you could start and do it at 7 and then go to 7.1 and 7.20. But there's some ways to help yourself out. So one would be to do this. Like, you know, we've got 51, and then we subtract 49, and that's a difference of 2. And then we could also do 64 minus 51, and that's a difference of 13, which tells me that this number, whatever the square root of 51 is more than likely on my number line going to be much closer to, say, the number 7, okay? It's probably going to be much closer to 7 than it is 8. So I'm going to start by checking, 7 squared. So here's 7.0 squared, that's 49, and 7.1 squared. Okay, that's 50.41. So remember, what I'm looking for here is to see if 51 falls between 7 squared and 7.1 squared. You can see right here that it does not, okay? Again, just to illustrate it a little bit, we've used inequalities. The calculator won't let me, type out an inequality, but what I could do is show this, okay? 49, then we're evaluating 51, and then we know that 7.1 squared is 50.41. So what we're looking at here is, does 51 fall between 49 and 50.41? No, it doesn't. Not at all. So now I have to check another interval. So here is the interval between 7 and 7.1. So now what I'm going to check is 7.2, and I'm going to square that. Now, does 51 fall between these two? Okay, does 51 fall between 50.41 and 51.84? Absolutely it does. So now I know that the square root of 51 is going to fall between 7.1 and 7.2. In ALEKS, you have to give one of those two as the answer. You have to figure out which one. So here's how I recommend you do that. The first thing I would do is I would do 51 minus 50.41, and that's a difference of 0.59. Then I'm going to examine 51.84 minus 51, and that is a difference of 0.84. So, which one of these two is closer to the square root of 51? Is it 7.2 or 7.1? Well, how I determine that is whichever difference is smaller, and in this case it's 0.59. So the number that the square root of 51 is closest to is the term that I squared to get 50.41, and that is 7.1. So if that's the case, then what I want to do, sorry about that, what I want to do here is come back and I would enter 7.1 and double check that. And the nice thing about that Desmos calculator, like I said, is you kind of have it in the background here, so you can kind of see it. You can move this around if you need to, but 7.1, Oh, I have to fill in the box. Sorry. 7.1. And I'll check my answer. And that's correct. I'll do one more just to kind of, again, get you familiar. So here you're looking at 113. What two perfect squares does that fall between? So again, you need to come back and check, okay, is it between 81 and 100? No, it's bigger than 100. It is the square root of 113. Again, I'm writing that down just so I don't forget it. So it falls between 100 and 121. Now again, to start figuring out the interval. Again, here's why I do that. 113 minus 100 is a difference of 13. 121 minus 113 is 8. So here's what I know. I know that the square root of 113 falls between 10 and 11, okay? Which one is it closer to? Well, it's closer to 11. So the first interval I'm going to check is I'm going to start at 10.5. I'm not even going to bother going all the way down here like I did with 7. And the reason I started on the low side with 51 is because it was way closer to 49 than it would be 64. So here, since I know it's way closer to 11 than it is 10, I'm going to start with 10.5, and I'm going to square that. Okay, so that is 110.25. All right, I have to get to 113. So that's on the low side, so 113 could fall there. Let's see if it falls between 10.5 and 10.6. So 10.6, and I square that. Again, I look, does 113 fall between these two numbers? No, it's bigger than that. So the chances are then, if I do 10.7 and square that, okay, now I have these two numbers. So now I have 112.36 and 114.49. So the square root of 113 is going to fall between these two numbers. But which one is it closer to? This is one of those ones where, like I said, I would think you maybe could look at it and see, but if not, don't hesitate to do the extra subtraction step. Just do this, 113 minus 112.36, and that's a difference of 0.64. Then do 114.49 minus 113, and that's 1.49. So since this difference is the smaller difference of the two, then I know that the value squared to give me 112.36 is the number I'm looking for. And we got this number by squaring 10.6. So that means my answer is going to be, in this ALEKS problem, 10.6. And I check. Okay. And that's correct. All right, so hopefully this will give you kind of a good frame of reference. Question number 2. This one is like super easy when you get these questions. Again, find two consecutive whole numbers that the square root of 41 lies between. This, you just come here. Find the two values that 41 falls between. It doesn't fall between 16 and 25. It doesn't fall between 25 and 36. It does fall between 36 and 49. So that means the square root of 41 falls between 6 and 7. And again, how did I find that? I know, I'm going to move this just a little bit for you to see. I know the square root of 41 falls between these two, so that means that it falls on a number line between 6 and 7. Okay. All right, and then in number 3, so this one, what you want to do, the first thing is just go ahead and evaluate the square root. It's 87, and that is equal to 9.32. So here they've given you a number line, 9 and 10. You have to plot this point as close as you can. So what I would do is each one of these is a tenth. See, 9.1, 9.2, 9.3, 9.4, 9.5, 9.6, 9.7, 9.8, 9.9, and then 10. This is at 9.32. So what I'm going to do is I'm going to find 9.3. 1, 2, 3. And then it's 0.2. So I'm just going to go just a touch past the line and drop it. And more than likely, it'll be close enough, okay? If it's bigger than 0.5, obviously it needs to be past the middle. If it's 0.5 or less, it needs to be closer to the side, okay? But just remember, whenever you evaluate this, like I did here, just one more time, when you go to evaluate this, the whole number will be there. Then to figure out this, you're going to look at this decimal point and then how far past that 10th mark do you go, and that's what kind of tells you. So again, this one I put at 9, I put right here because this is 9.3 at this mark, and then the 2 means it's just a little bit bigger than that, okay? So that's it for today on this lesson. You can complete this ALEKS assignment. You have until Friday to get it done and scored. You have unlimited attempts on every question and whatnot. So I don't think it's going to be an overly difficult task for you to complete. And I hope this video was helpful. So thanks for watching, and I'll see you all when I get back from paternity leave.